Thanks for tuning in. Arnold Kisembo here. This is Kisembo Academy, and today we are going to do some worked examples, examination style worked examples that are covering numbers that are related to topics such as the square roots, reciprocals, surds, and the square. Now, so let's get started with this number 64 to the power negative a third. Let me rewrite it here. We have 64 to the power negative 1 over 3. Divide that by 27 to the power negative 1 over 3. Now, from your laws of indices, you know that a number to the power negative, let's say if I said a to the power negative 1, this is the same as saying 1 over a. So it means if I said a to the power negative 1 over 2, that is the same as saying that can be converted into, 1 over a, and that's this whole thing is to the power half. In other words, the negative, if for us to remove the negative, we simply find the reciprocal of whatever it is that we have here. This is from your laws of indices, so it's what we're going to do here. So from here, I'll simply say this is going to become 64 to the power negative 1 over 3, and I'll multiply that, I'll divide that by 27 to the power negative 1 over 3, like that. So now let's remove that negative right there. So this is going to become 1 over 64. This whole thing is still to the power a third. Divide that by 1 over 27, of course, and that thing is to the power a third. Now take note that when we say to the power a third like that, it simply means that this a third here, this power applies to the 1, and it also applies to to the numerator and the denominator, right? So this is the same as saying 1 over 64 to the power a third to the power a third, divide that by 1 over 27. This is to the power a third. I'm only trying to go as slow as possible so that I do not lose anyone. Okay, so this is going to become, now 64 to the power third means that we are trying to find the third root of 64. So let's go ahead and find the third root of 64. So I'm going to do some side work here to find the third root of 64. For some of you, it's just as simple as punching this in a calculator. So let's get started. So that is by 2. That's going to be 32. By 2, that's going to be 16. By 2, that's going to be 8. By 2, that's going to be 4. Divide that by 2, we end up with 2. Since we are finding the third root, it means we are going to group these ones in groups of 3 since it's the third root. So in those two groups of 3s, we shall just pick 1, 2 here and 1, 2 there. Then we shall say this is 2 times 2, which is 4. So it means that the third root of 64 is 4. So I'll simply come here and say that 1 to the power a third is 1. Divide that by 64 to the power a third, which is the same as saying the third root of 64. That is going to give us 4. Then I shall divide this by 1 to the power a third is 1. Divide that by 27 to the power a third. Let's do some side work to find that. So I'll do it here. So this is 27. By 3, that is going to give me 9. By 3, that is right there is 3. And since we're trying to find the third root, so I'm going to group these ones in groups of 3. And then I'll just choose 1, 3. And so the third root of 27 is 3. So it means this is going to become 1 that over 3. So after simplifying our working like that, we shall continue by saying this is a quarter. Multiply that by 3 over 1. And our answer is 3 over 4. So that becomes the answer to our question right there that was saying without using mathematical table or calculator, simplify. So we have simplified. So moving on to the next number, we are being required to simplify this expression. As you can see, this expression, giving your answer in the form of a root b, where a and b are constants. So let's write it here. We have root of 20 minus root of 45 plus root of 1 to 5. So what we're supposed to make sure that our answer is in this form, a root b. So what we do here is that we look at these numbers here under the square root. When we look at those numbers under the square root, we seek to find, factors. By factors, factors are two numbers that you can multiply with them together in such a way that one of the factors is a number whose square root you can get. Let's do, for example, let's look at 20. Let's analyze the factors of 20. I'm doing some side work here. So the factors of 20, we have 1 times 20, we have 2 times 10, we have 3 it's not there, we have 4 times 5. Yeah. So so that the factors of 20. Now you realize that for factors of 20, 4 times 5 will give you 20, and of these two factors, we know the square root of 4 to be 2, right? So that's what I shall do here. So instead I shall come here and say that the 20 is going to become 4 times 5 minus. Okay, so let's proceed. We'll go to 45. So let's do the factors of 45. So the factors of 45, this is what we have. 45, we have 1 times 45. 2 doesn't fit there. We have 3. We have 3 times 15. Then we have 5 times 9. Then from this one, 5 times 9, from the two factors, you realize that we have a factor whose square root we know. We all know that the square root of 9 is 3. So we shall go with that one. So I'll come down here and say the 45 up here is going to become 5 times 9. Then plus 1 to 5. Let's look at the factors of 1 to 5. So again, factors of 1 to 5, we have 1 times 1 to 5. Of course, 2 is not there. 3 does not fit in there. 4. So here we have 5 times 25. So from here you realize that we have a number whose square root we can get, which is 25. So that's the one we shall use here. So this is going to become plus, 5 times 25. So after splitting our numbers there, by making sure that we are pairing them up with a number whose square root we can get perfectly, then we can go ahead and start. This is the same as root of 4 times root of 5 minus, this is the same as root of 5 times root of 9 plus, this is root of 5 times root of 25. And of course here, the square root of 24 is 2, so this becomes 2 times root of 5. We do not know the root of 5 is going to give us an irrational number, so we leave it as root of 5 minus the square root of 9 is 3, so this is 3 times the root of 5, then plus this is the square root of 25 is 5, so it becomes 5 times root of 5. So from here, remember our answer is supposed to be in the form of a root of b. So we want an answer where it's in the a times the root of b. Okay, so from here we can continue, and now remember here, you see when you see this, we are seeing that this is a surd root of 5 here, we have root of 5 there, we have root of 5 right there. You see, you should look at this like the way you would see maybe it is 2, x. This is minus 3 root 5, so it's like minus 3x. Then this is like plus 5 root 5, then this is like plus 5 root 5, yeah? I mean 5x. I have simply made the surd as x. So if you look at this, you realize that 2 minus 3 is negative 1, negative 1 plus 5 is positive 4. It becomes 4x. So the way you would do this for algebra, it's the same way you'd look at this. So this is 2 minus 3, which is negative 1, plus 5, which is 4. So the answer here is 4 times the root of 5. That's the answer. That's how you look at it. So I think we've answered the question. The question required us give your answer in the form, as you can see, give your answer in the form of a root b, which is this. So meaning our value of a here is 4 and our value of b is 5. This right there is the answer. Moving on, use the prime factor method to find the cube root of 3375. So the prime factor method here, it's the answer, it's 3375. So use the prime factor method to find the cube root of 3375. So that's 3375 right there. So we shall divide this by 3. A prime number like 3. When you divide that by 3, we have 1125. If we continue to divide that by 3, we shall end up with 375. Divide that by 3. There we have 125. Then we can divide that by 5. When we divide that by 5, we shall end up with 25. When we divide that by 5, we shall end up with 5. Now that is, we have factorized it, like broken it down like that. Now they're asking us to find the cube root. So the cube root means that we are going to divide this in groups of 3. The factors, group them into 3s. So that's the first group of 3 number. That's the second group of 3. So in each group, we pick 1. So here we pick 1, 3. Here we pick 1, 5. And so we shall simply come here and say it's 3 times 5. That is 15. And so that is the cube root of that number. The next number, we have, without using tables or calculator, evaluate 0.25. Let me rewrite it here. We are supposed to evaluate 0.25, multiply that by 2195 minus 1795, multiply that by 0.25. Now with such numbers, they want to see if you know about factorization. From here, you can see that we are having 0.25 as a common factor. So we factor it out. We shall say 0.25, put it outside brackets, into what remains there is, it's like getting this whole thing, divide that by 0.25. What do you remain with here? That's what you put here, 2195 minus getting this whole term, which is this times that, divide that by 0.25. What do you have remaining? What you have remaining is 1795, like that. So of course, after showing that you know how to factorize the thing, the rest is 0.25 into brackets. Then you can go ahead and subtract that. You can even use your calculator to do that. Then there we have 400. So this condensing, it gets to being 0.25. Multiply that by 400. This 0 goes, 25 moves forward. That 0 goes, 25 moves forward. You have 25 times 4, which eventually is 100. So the answer there is 100. Moving on to the next, they're asking us here, find without using tables the square root of 2500. Multiply that by 1764. So they want us to find the square root of that without using tables. Now, of course, if you're not using tables, when you're trying to do the square root, you can either find the square root by prime factorization, or you can use long division. Yeah, you can use one of those two. Now, me, I'm going to use prime factorization to show you how we can go ahead and find the square root of each of these numbers. So let's first let's start it with 2500. So we shall begin by 2500, divide that by 2. What do you get? You will get 1250. By 2, what do you have? When you divide that by 2, you have 625. You can go ahead and divide that by, is it 3? Now let's divide it by 5. 3 is not divisible by that. When you divide that by 3, by 5, we shall end up with 125. And of course, if we continue to divide that by 5 again, we shall end up with 25. And if we divide that by 5, we shall end up with 5. So the square root of this, now because we are finding the square root, it means we are going to group them in groups of 2. Put that in groups of 2. Put this in groups of 2. And also put that in groups of 2. So from each group, select just one number. So in this case, it's going to become, here we shall pick 2. Multiply that by here, we shall pick a 5. Even here in the last unit, we shall pick a 5. So this means it's going to be 2 times 5, which is 10. 10 times 5, which is 50. So it means that the square root of 25 is going to be 50. That's what we've gotten. Then let's do for 1764. I'll use a different ink here. 1764. We shall begin that by 2. What do we have when we get 1764 and divide that by 2? We shall end up with 882. Divide still that by 2. When you divide that by 2, you end up with 441. When you divide that by 3, when you divide that by 3, we shall end up with 147. Divide that by 3 again. Divide that by 3 again, we shall end up with 49. Then divide by 7, you end up with 7. So we shall group those again in groups of 2. Since you are finding square root, when we group those in groups of 2, we shall pick a 2 here, pick a 3 here, pick a 7 here. So this means it's going to become 2 times 3 times 7. 2 times 3 is 6. 6 times 7 is going to give us 42. So moving back from here, this means all this that I was doing was more like, side work. Or you could actually, not exactly side work, you could show the working of how you're getting your square roots. Then from there, after getting that, you can go ahead and, let me rewrite that down here. So this is the square root of 500. Multiply that by 1746. This is the same as the square root of 500. Multiply that by the square root of 1746. So the square root of 500, square root of 500, we already got it as 50. So this is 50. Multiply that by the square root of that, which we got as 42. So you simply go ahead and multiply those two. We have 50, multiply that by 42, and we shall end up with 2100. That's the answer. Moving on, we have here a surd. They're asking us to express this, express that with a rational denominator. Now, what do we mean by a rational denominator? It means a denominator that can be divided. So how do we go about this? This is 1 over the square root of 5 minus the square root of 2. So to make it into a rational denominator means that we are going to rationalize the denominator. How do we do that? We do that by multiplying the denominator by the inverse or the conjugate. So in this case, this is root of 5 minus 2. What we shall do is we shall multiply it by root of 5 plus 2, like that. What we do to the denominator is what we do to the numerator. So this is going to become, of course, the top one becomes root of 5 plus root of 2. Divide that by. Now, do you realize that this the denominator here is in, when you there is this identity that a squared a squared minus b squared is the same as a plus b into a minus b, right? So meaning that if you see that this a plus b, this is like a, that is b, this is also a, this is b. So when you look at this setup here, it's like this a plus b into n minus b is what you're seeing in the denominator. So meaning this can be the same as this. So it means that in our denominator here, we can simply go ahead and say this is the same as root of 5 squared minus root of 2 squared. That is what that is where it's coming from here. So from there, we can go ahead and simplify this. So this becomes root of 5 plus root of 2. Divide that by, this is definitely 5 minus 2. How does that come about? This square root sign goes with that. This square root sign dies with that. So you remain with 5 minus 2. So from here, what you remain with is the square root of 5 plus the square root of 2. Divide that by 5 minus 2 is 3. So from here, you are able to see that we have been able to rationalize the denominator. In other words, at the beginning, the denominator had irrational numbers. Now, after doing this, now the denominator, you can see, has a rational number. So it means we have answered the question which was requiring us to rationalize the denominator. Express this with the rational denominator. So we finished. That is how we do it. That's the answer. Moving on. So here we have express this in form of a plus b root 3. Hence, evaluate that correct to 3 significant figures if root of 3 is that. So in other words, this question has two parts. The first part means that we're supposed to first express this in terms of that. After expressing it in terms of that, then we go ahead and find the value of this, knowing that root of 3 is equivalent to that. So let's first do the first part. So the first part is express 1 plus root of 3, divide that by 2 plus root of 3. Express it in this form. So for us to express it in that form, it means we're supposed to rationalize the denominator. In other words, we're supposed to make sure that the denominator has a rational number. And how we do that? By multiplying the numerator and the denominator by the conjugate. So in this case, this is going to become 2 minus root 3. That's what we do. We do the same here, which is 2 minus root of 3. So after doing that, of course, we're definitely going to multiply. So here we open brackets. This is 1 times this second bracket, which is 2 minus root of 3. Then this is plus 3. So this is going to become plus root of 3 into 2 minus root of 3. That divide this by what is in the denominator here. The denominator is in the, like I had mentioned in the previous number, it is a plus b, a minus b. So this is the same as saying 2 squared minus root of 3 squared. So from there we proceed. This is going to be, we open brackets. This is 1 times 2 is 2. 1 times negative root of 3, that is negative root 3. Then root 3 times 2 is plus 2 root 3. Then root 3 times this times that, it's going to be, well, again, when you multiply two numbers that are roots, you get that very number. Let me repeat it here. If I want the square root of 25, multiply that by the square root of 25. We know that square root of 25 is 5 times the square root of 25 is 5. So 5 times 5 is 25. You realize that the 25 ends up being the same number, okay? So meaning that when you're having two square roots that you're multiplying together, the answer is always that very number. So that same logic is what we're applying here, that we have the square root of 3, multiply that by the square root of 3, the answer will be 3. So that will be minus 3. Divide all that by, this is 2 squared, which is 4, minus, of course, root of 3 squared, that square root sign goes with that, you remain with 3. So this is going to become, on the numerator, we collect like terms. This is going to become 2 minus 3 minus root of 3 plus 2 root of 3, all that divided by 4 minus 3, which is 1. So this is going to become, now 2 minus 3 is going to become minus 1. Then negative root of 3 plus 2 root 3. Now when you look at this, there is an invisible one here. It's like this is minus 1 root 3. You can call this as, for those that might get confused, if you look at this, it's the same way you would treat negative 1x plus 2x, something like that. Negative 1x plus 2x is going to give you x. So it's the same thing here. Our value of x in this case is the square root of 3, or the surd called root 3. Okay, so it means that here it's negative root 3 or negative 1 root 3 plus 2 root 3. So it's negative 1 plus 2, which is going to give us positive 1. So we shall remain with plus root 3. So it's going to become negative 1 plus root 3, divide that by 1. So if you look at that, this from there, we are going to simply end up with negative 1 plus the root of 3 as the answer. Now, do you realize that this has been expressed in this form that was given to us in the question? The question required us to express our answer in this form, and so our answer is in the form of a plus b root of 3. And realize that our value of a here is negative 1 and our value of b is 1, like that. So that's the answer. Now we've answered part A of the question. Okay, now the question continues to say, hence evaluate this expression, which is the same as before, evaluate this, which is the same as this one that we have just expressed. So evaluate this, correct to 3 significant figures if the root of 3 is this. So our answer we got, meanwhile, remember it's negative 1 plus root 3. So let me write it here, it's negative 1 plus root 3. So negative 1 plus root 3 is going to be equal to negative 1 plus our root of 3. Now our root of 3 is 1.732. So I'll come here and say it is plus 1.732. And what answer do we have? 1.732 minus 1 is definitely going to end up giving us a 0.732. Now they want our answer to have 3 significant figures, and that is exactly what we have done here. We've gotten our answer, and it is to 3 significant figures, and that's our answer. So we have finished with that one. Moving on to the next number. The next number here, they're still asking us, without using tables or calculator, simplify this one. Of course, when we are simplifying numbers like this, let me write it here. We write the number here, root of 30 plus root of 35, divide that by root of 6 plus root of 7. Again, we are going to rationalize the denominator by multiplying the numerator and denominator by the conjugate, like that. This is how we simplify it, by first rationalizing the denominator. So from there we shall continue. Now at the top we open brackets, or we multiply the 2 brackets. Remember, this is another bracket on its own. So this is root of 30 into root 6 minus 7. So this is root 6 minus root of 7 plus 35 into root of 6 minus the root of 7. Divide all this by the things at the bottom. Like I said, this will end up being root of 6 squared minus root of 7 squared. It's coming from the identity that I explained earlier. So from there, we'll go ahead and multiply 30 times 6. What do we have? 30 times 6. We get the square root of 180. So on top we have 180. Then we have 30 times 7 minus the root of 210. Then this is root of 35 right there. I had missed that. Yeah. So root of 35 times root of 6. So we shall go ahead and ask ourselves, what is 35 times 6? 35 times 6 that is plus root of 210, then root of 35 times 7. 35 times 7 is this is going to become minus 245. We shall divide all that by, of course, this goes with that, remain with 6, minus this goes with that, remain with 7. So from here you can see that this negative root of 210 and positive 2 root of 210 will cancel out. You'll end up with the square root of 180 minus the square root of 245. Divide that by 6 minus 7 is negative 1. So that being negative 1, of course, if this is going to make, if it to divide through by negative 1, making the numerator positive, this becomes definitely root of 180 divided by negative 1 will give you negative 180. Then negative 1, divide that by that will become plus root of 245. So from there, all we just have to do is to just simplify it further. And we can simplify it further by simply finding the factors of 180 or the factors of 245, and we see which ones we can use. We just need one of the numbers to be having a perfect square root, and we simplify it further. So let's start with 180 here. 180 has 1 times 180. We have 2 times 90. We have 3 times 60. We have 4 times 45. We have 5 times 36. You realize that 36, we can get the square root of 36 perfectly, unlike the rest. So we shall choose this pair. And we shall simply come here and say this is minus into brackets, which is 5 times 36, like that. That is plus. Now let's do for 245. So for 245, this is like side work. So 245, I think it can't be divisible by 2, can't be divisible by 3, can't be divisible by 4. Let's start with 5. So this is going to, of course, at first it's 1 times 245. Then we have 5 times 49. Yeah, you realize that 49, the square root of 49 is 7. So we can also go ahead and say this is going to be plus under the square root of 5 times 49. Okay, so from here we have, of course, this is going to be the same as the root of 5, multiply that by the root of 36, plus the root of 5, multiply that by the root of 49. So from there we shall end up having this as the root of 36 is 6, so it's root of 5. Oh, I am forgetting this negative here. Remember, this negative is applying the one here. It's applying here. This negative is applying there. Then so it's still very alive in here. So that's going to become negative 5 times root of 36, which is 6. And that's going to be plus root of 5 times 7, like that. So definitely this is going to become negative 6 root of 5, okay, plus 7 root of 5. So this is the same. If we are to rearrange this, this is the same as saying 7 root of 5 minus 6 times the root of 5. So from there we can have 7 minus 6. We end up with our answer being the square root of 5, but with a negative. I mean, no, it's 7 minus 6 is 1. So it's more like 1 times the root of 5, which is just simply saying root of 5. So our answer is the square root of 5. And that's how, without using tables or calculator, we have simplified this. So moving on to our very last number, it is kind of similar like the one before, only that now here they are asking us to express this in terms of that, and afterwards find the values of A and B. So we shall do just that. So just like the way we've been doing earlier, we are going to first of all begin by rationalizing the denominator. So this is root of 3 plus the square root of 2, like that. So we rationalize the denominator by multiplying the numerator and denominator by the conjugate. So that is 3 minus the square root of 2. You do that on top and on bottom. Root of 3 minus root of 2, like that. So from there, this is going to be equal to, we multiply. This is okay. Let me just rewrite it here. Root of 2. Okay, multiply that by root of 3. Okay. Then that is bracket, then plus, just a plus root of 2 times negative 2. So I shall say root of 2 times negative root of 2, like that. Divide all that by the things in the denominator. Again, like I have been mentioning earlier, this is the square root of 3 squared minus the square root of 2 squared. So this is going to become 2 times root 3, which is going to be root of 6, then square root of 2, this is plus, then square root of 2 times negative 2. Remember, like I said, when you're multiplying two surds that are the same number, like root of 2 times root of 2, the answer will be 2. So this is plus negative 2. Of course, this positive and negative will end up see us having a negative. Divide that by, of course, the square root. The square root sign goes with that. The square root sign goes with that. In the denominator, we shall end up with 3 minus 2. So from there, we shall end up having our square root of 6 minus 2. Divide that by 3 minus 2, which is 1. So in other words, our answer here is simply root of 6 minus 2. Now take note, when we get back to our question, they're telling us that we're supposed to express it in this form of a plus b root of a plus root of b. So if you look at this, it's supposed to be expressed in terms of a plus b, a plus root of b, right? Yeah, a plus square root of b, like that. And so if you were to rearrange this thing here, a is negative 2 plus square root of 6. If you compare this is now the form. If you compare that with a plus the square root of b, you realize that our value of a here is negative 2, and you also realize that our value of b is 6 right there. That's our value of b. So if you go back to the question, they are asking us that first of all express the answer in terms of that, and then also find the values of a and b. So it's important that whenever you finish a number, go back, read the question to see whether you have answered the question, and from here the question requires us to find the values of a and b. So it's important that finally you say therefore our value of a is negative 2 and our value of b is 6. You missed that, it means you've not fully answered the question. So that's our answer, and that brings us to the end to this session with just those simple numbers. However, like I had mentioned earlier in an earlier number, I had mentioned something to do with that the way we can find, there are two ways of finding the square root of a number. You can find the square root either by prime factorization or by using long division. Prime factorization, finding the square root by prime factorization, is normally done when you're dealing with just small numbers. But now what if they asked you to find the square root of a number like 2, 3, 1, 1, 4, 7, 8? Now this is a very big number, and if you're to use, if they ask you to find the square root of this number without using a calculator, and you go using the prime factorization route, it will be a very long process. So with such big numbers, we use what we call long division. Now, how to use long division when prime factorizing, I will do that tutorial in a separate video. I'll do some worked examples so that I bring out the picture more clearly and more slowly. So if you think you are interested in that kind of video, let me know in the comment section below. Otherwise, for this session, I'll end here. Thanks for watching. My name is Arnold Rangakuramia, and this is Kisembo Academy. Take care.